One of the ways that you can ensure you write an awesome scientific paper instead of a dull one is by the clever use of statistics to summarize your data. Unfortunately, this is not always easy, and many writers fill their papers with means, medians, standard deviations, standard errors, and the like, leaving their readers wondering, what was this paper all about? My name is Jeffrey Franck. I'm a statistician and the CEO of Stat59. In this video, I will show you some simple tricks on how you can use summary statistics to impress your readers and wow the peer reviewers. So in this lesson, I'm going to talk about this data set. We can look quickly at this data set. What this data set is a group of simulations, and each one of the rows is a simulated patient. So for each simulated patient, we know their age, their triage score, which simulation they were involved in. Then we also know their time to triage, time to get a room, time to see a medical doctor, time to be disposed, and whether they were adult or pediatric case. So this might represent a typical research project. Now, how are we going to summarize this data to make it useful for our readers? We're going to start by looking at some of the continuous variables. The continuous variables are things such as age, time to triage, time to room, and you can see how they're written up on our data set. Age, for instance, could go anywhere from 1 to 100. We see the time, which is the time from arrival at the simulation till the time of triage, could vary from 1 to 2000. These are continuous variables. So, what statistics are commonly used to summarize continuous variables? Well, most of us will have seen these. These are things such as measures of central tendency. So, measures of central tendency tell us what is the middle of our group. This is the mean, the median, and the mode. And then measures of variability. So, what's the range, standard deviation, or interquartile range? And these are commonly used statistics. The mean is probably the most common of these statistics, but what is it? What is the mean? Well, the mean is the sum of all the values divided by the number of values. And as statisticians, we like to express it like this. Now, what are the advantages and disadvantages of using the mean? We see it used all the time, and why? Well, the advantage is it's what we statisticians call it the minimum variance best estimator. If you really want to know the center of a population, then the mean is the best estimator, and it's very easy to calculate. The disadvantage of the mean is that it's very easily influenced by outliers. So in this situation with our simulation, if we had, for instance, a group of simulated patients where one patient was 100 years old and all the other ones were teenagers, we would see that that single outlier, the age of 100, would vastly skew our mean. And the other thing is that for the mean, you need to have all the x values to calculate it, meaning you need to know all of the values. In things like simulation, sometimes we have censored data where we don't know all of the values, in which case we need to look for another way to summarize the center. What is the median? Well, the median is another way to look at the center of a value. And that's the value that separates the highest half and the lowest half of the sample. It's a little bit trickier or more laborious to check, to calculate than the mean. So to calculate it, we rank the observations from low to high, and we take the middle value if there's an odd number of observations, or the average of the two middle values if there are an even number of observations. What's the advantage of the median? Well, it's much less sensitive to outliers. For instance, as we talked about, if our simulated patients were all teenagers and one of them was 100 years old, our median would actually be in the range of teenagers. It can be used when the n values are not known for censored data, works very well for skewed populations, and it gives reduced importance to outliers. The disadvantage, of course, is that by ignoring outliers, important data points may not be summarized. For instance, maybe it would have been very important for us to understand that there was a simulated patient with an age of 100 in our data set, and that will be lost in the median. The range is one of the simplest ways to present the dispersion of the data. And this is often presented as the highest and lowest value. For instance, we might have a range of 14.5 to 19.8. Or if we talked about our simulated patients, we might have a range of age from 1 to 100. Standard deviation is one of the more technical ways that we can be more precise about the dispersion or within our data. And the other word we use for this is variance. And I'd like to just put to rest a common misconception about what that means. So variance is the average distance from the mean that is then squared and summed up. Okay? And why do we square it and sum up? Well, basically we need to square it before we sum it up, otherwise they would simply cancel each other out. So basically, to calculate the variance of a population, for instance, for the age, we'd find the mean age of each of the students or each of the participants in the simulation, and they would then take their age, subtract the mean, square it, and then sum it up. Standard deviation is simply the square root of the mean. It's preferred simply because it keeps the same units as what we're measuring. So a really very, very important thing to remember that standard deviation is not the same as standard error. I don't think you necessarily need to memorize what each of these things are in your head, but just remember they're not the same. The standard error is the standard deviation of an estimator. Okay, so we would talk about the standard deviation of the age of the participants in our simulation. But if we were trying to estimate the mean, we would talk about the standard deviation of the mean. It's a little tricky, but super important not to mix them up. There are other point estimators for central tendency, things like the mode, which is simply the most commonly observed, and the trim mean. Some people like to trim out part of the very high and very low values. For instance, maybe trimming out the top 25% and the bottom 25%, and then taking the mean of that. And another source of variation, another way to estimate variation, is by the interquartile range, which is simply the value at the 25th percentile and the value at the 75th percentile. One of the major ways we can make this super easy for our readers is simply by using plots. Here, if you look to the right, you see how I would describe this as a summary statistic. The mean pulse rate for the 2,223 patients was 86 with a standard deviation of 19. The minimum pulse was 13 and the maximum was 196. Not always so easy for us to visualize that in our head. On the other hand, if you look at the graphical summary, we see this very quick summary, and we can read very quickly from the plot. We can see the average is somewhere around 100, a little bit less than 100. We can see that most people had a pulse that was in the range of sort of 75 to 125, and we can see that nobody had a pulse of 200 and nobody had a pulse of 0. This is a simple way to summarize your data. We're going to move on now to discrete variables. Discrete variables are cases when the variable, rather than being a number, such as on a number line, can only take on certain values. For instance, going back to our simulation study, the value for triage is the only possible values are 1, 2, 3, 4, and 5. For simulation, there were only 4 simulations. And then at the very end, our age, we saw you were either adult or pediatrics. These are 2 choices. So these are discrete variables. Now, very, very common error is to calculate the mean of a discrete or particularly categorical variable. For instance, on our previous page where the triage level was 1 to 5, or a very, very common use is a Likhert scale. Now, these should not be calculated as a mean in general use unless you've proven the assumption that you can. So very common error is to calculate the mean. Instead, we should present them as a frequency table. Frequency tables are super easy to construct in almost all pieces of software. Here, we just did a simple frequency table that said there were 10,000 adult patients and 2,000 pediatric patients. Again, presenting these as a frequency table or writing them in your paper is easy, but one of the best ways to present these is through the use of a histogram. So here we could describe it as this. There were 1,359 CTAS level 1 patients, 2,735 CTAS level 2 patients, 5,915 CTAS level 3 patients, 2,718 CTAS level 4 patients, and 111 CTAS level 5 patients. Or we could present this very beautifully as this CTAS score versus number of patients histogram. And we see very simply the 5 levels of the CTAS score and the number of patients. Again, for your reader, this will be much easier to understand. Likhert scales, as we talked about, are one of the ways that it is very, very easy to make mistakes. Here we see a Likhert scale that says, is a website user survey. And the participants are allowed to answer a 1, as strongly agree, neutral, disagree, or strongly disagree. Remember that these are categorical variables. And one mistake that people often make is simply assigning numbers to this. So we will call strongly agree 1, agree 2, neutral 3, disagree 4, and strongly disagree 5. This is not a good way to analyze your data. There are other ways rather than using the Likhert scale to allow you to summarize those. If you want to summarize these, then you should just simply summarize them on a frequency table. And finally, just a push to show how important it is to adapt how you will display your data to what you're trying to prove. Sometimes things such as the mean age was 47 years with a range of 17 to 85 are very simple. Other times, plots can make things much easier. Number one, the most important thing is recognize that when you are providing summary statistics, to make sure that it's easy for your reader so your reader is not confused as to what you're trying to prove. So in this video, we saw that the clever use of summary statistics leads to a huge increase in the quality of your research. So in the future, instead of a long narration of summary statistics, why not try using fewer but much more focused summary statistics and consider plots and tables to help you with your visualization. Both readers and peer reviewers will have a much easier time understanding your data, leading to a much greater impact. My name is Jeffrey Franck. I'm a statistician and the CEO of Stat59. If you would like to learn how the Stat59 web app can help you design, analyze, and report your own data while greatly simplifying the creation of summary statistics, please check out our website at www.stat59.com.